Hello and welcome back. Although this looks like an ordinary solid pipe, it's far from it. Through the magic of parametric design, it's actually a flexible, stable and fully adaptable model that you can adjust and change to your heart's desire with a single click of a button. Today we'll continue our journey into Fusion 360 with this new parametric pipe design, and we'll learn how to use the construction geometry in order to make our part more stable during design changes and iterations. But let's not waste any more time and start building this model. So when dealing with a part like this, it's usually very good to start with the bare bones, kind of like a skeleton of the part. Looking at this, you can quickly notice that it's just an L-shaped bend with two little T-junctions coming out of it. So to start doing that, we need to create a sketch for the main bend. We pick one of the axes here, let's say this one, and we start designing our sketch. We can start here in the origin, that would be a great start. And we have this kind of L shape like that. Now we need to constrain this. We need to dimension the pipe. This is 180. And for this one, I believe we don't actually have a value for it. Let's call it 100. We have this radius here. That's actually the inside radius. This is plus 20, 50. And then we click finish sketch. Now the important part now is that we need to create the little bends here. To do that, we could simply just create a sketch on this surface and then create a line like this and create a line like this. That would be very easy to do, but we're not going to do that because we want it to be we want the pipes to be very adaptable. We want to be able to change the angle and location of that. If we simply did a line like this, then this one we will only be able to change the location like this, and we will not be able to change the angle, which is not really what we set out to do. So in order to do that, we need to create construction geometry. That means we need to offset a plane from this area here to where we want our first T-junction to go. We have this option here where it says construct. We can click on the little arrow and click on the offset plane. We offset a plane from this one, and it's 60 millimeters. And only on this plane here, we will create our sketch. We'll create our sketch like this. Our sketch will be a simple line. We need to snap it to the center point, and then we make sure we don't snap it to anything else. Now we add some dimensions and constraints to this one. It's let's see if we have a height in our drawing. We don't actually have one, but that's fine. We can call it 60. And now we need to constrain it to this one. We put an angle constraint here and just call it. I guess it doesn't work with the 0. We put an angle constraint between this one, and I guess we can select this y-axis here, like this. If you are not able to select the y-axis, you can do like this: pre-select the y, and then add the other line, and then you can have the angle. We call this 90 millimeters, so it can be straight for now. Good. Now we need to do the same for here, but this time we create another construction plane. It's going to be an offset, but it's going to be an offset from this one, the XY plane. This we actually have a value for, and it's 80. Now we go back here to this plane, create another sketch. We try to snap it here. We do the same as before, like this. We try to pick the in this case it's the X axis. Still doesn't work. Pre-select the X. Click on sketch dimension. And then you select your geometry and you can select your angle like that. And here we can so one thing to note now, that 0 is not an option for this angle for some reason, but that's okay. We can select the y-axis and put it 90 degrees, like that. One thing to note here, we have snapped it to this one, but it didn't actually keep the constraint. So we need to constrain this with the coincident constraint here. Click on this. You have pre-selected the spot, and you notice it doesn't allow you to select anything else. You could actually select this one, but that's not really good. So the reason why it doesn't let you do this is because it doesn't recognize this geometry as inside the sketch. So to do that, we need to actually intersect or project some of these elements to our sketch. To do that, we need to go here in this section, click on the little arrow, create, and it's projection. In our case, intersect would be more suitable. We click on this and we click OK. Good. Now we can probably do the coincident constraint between this one and this one. Perfect. We need to set this distance like that, and then our sketch is fully constrained. Good. So now that we have our skeleton, we need to create some meat on the bones, basically. To do that, we create another sketch here. It's going to be on this plane. It's going to be a circle. Make sure you snap it to the origin. Put a dimension on it. And this is 40. Finish sketch. Now what we need to do is sweep the circle along this curve, straight to the top. To do that, we have a very specific command. It's called sweep. Click on this, you select the profile, which is the circle, you select the path, which is this line, and this is the sweep. It's going to create a new body for now. Now what you need to do is create the same for this one and this one. Again, you might be tempted to just go create sketch on this plane and this will work perfectly fine. You might be able to create a sketch on this one and select like an offset and start from here to here, and that'll be perfectly fine, but that's not really the correct way to do it. The correct way to do it is to create a point perpendicular to this line in this point, or in this one, it doesn't really matter. I'm gonna do it in this one because it's not inside the part. So again, we go to create construction element, and this time we're going to choose plane along path, and this one will basically, you select the path and this will create a plane that is perpendicular to this, and it can go from one point to the other of your geometry, and you can control that here with the proportional distance. 1 means 100%, 0 means 0%, so we're going to go with 1. Now we create another sketch here, create a circle, make sure you try to snap it to that, and then we're going to check if it actually snaps or not. This is 26 in our drawing. Now try to move it around, you see it's fully constrained, it's black, it's okay. Good, now we extrude this. No, sorry. We could extrude it, it's basically the same thing, but we might end up changing this curve to maybe not just a straight line in the future, so it's better to have it sweep. Select the profile, select the path. This time it's going to pre-select cut, but we don't want that, we want it to join. Good. Perfect. Now we need to do the same for this one. You should be pretty well versed in doing this now. Create a plane, create a sketch, create a circle. Dimension the circle, finish the sketch, and create the sweep. Join. Okay, perfect. So that's fine. This is really shaping to be to look pretty much like our part. Now we just need to create the flanges, and for these ones we will create another sketch on this plane or on the surface, doesn't really matter. And here we will start drawing this this flange. How we're going to do that? First we have like a central circle like this, and then you have two smaller circles like this, and in between those circles you have lines, for example like this, and here this will snap it to the little X means it's going to snap it to the circle, and it'll create a coincident constraint automatically to this, see? But however, if I snap it here to the circle and here I move it along, and you see this symbol here, this means it's going to create a tangency constraint. So this is actually tangent to this circle here. You can create it manually using this one, but it also kind of creates it automatically like that, if it's easier for you. Sometimes it's easier, sometimes it can create issues. Right here we just create another tangency constraint. Good. Right, now we need to get rid of these inner lines, inner edges, and we go to the trim tool and we just select them like that. We see a lot of warnings, but we don't care about them right now. Now we need to recreate the tangency constraints between the circle and the lines in every point. Here and here. See, this one we already had it, but it disappeared. Sometimes it does that when you cut things. This circle here we need to set the distance. You can see now that it creates a radius and not a diameter. So that's why it loses some of the constraints, because it's not the same element anymore. This one it has to be, let me see, so 70 divided by 2, 35. This one is 35 divided by 2. This one again is 35 divided by 2. This one and this one need to be basically symmetrical, so there is actually a constraint for that. It's called symmetry. You click on this one, you select this circle and this circle, and then you need to select the symmetry line, which is or plane in this case. Let's see, if I click on this axis, yeah, because it's a sketch, you can go with the line, and now this will be symmetrical. You need to have a coincident constraint between this point and this axis. This is the y-axis. Good. And now we need to have a distance between this and this. It's 80. And our flange is fully constrained now. Finish the sketch, extrude it. The other way around. Minus 10 millimeters. It's join and it's fine. Good. Okay. Next is the little holes on these sides. We're gonna go with a sketch here. We're gonna use the hole command for this, but for that we need a point. We go to the create. We try to find a point here. Point. We can actually snap it to this one. Yeah. If we put it here, it's actually snapped concentric to this one. So that's pretty good. You could probably do a coincident constraint between this point and the circle, and it'll do the same thing. So finish the sketch. We will go with the hole. Select the point. Select the size of the hole. That's 12 millimeters, and here we can go up to, and it'll prompt us to select the surface. We'll select this one and click OK. The other hole is symmetric, so we don't need to create the point again. We can just use this one, create mirror. We select here object mirror, it's a feature, not the whole body. We select the object, which is the hole, and the mirror plane is this plane. Click OK, and we have the other hole. Alright, now, need to create the flange on the other side. We will select this face here, and we'll create another sketch. For this one, we will need to create a rectangle at first. And there are actually two types of rectangle, and one of them is perfectly suited for our application here. And it's this one. Not a 2-point rectangle. If you go into rectangle here, you have the center rectangle. You can select this, it'll snap to the center of the circle. It's actually pretty good in doing that. And then you just create a rectangle around that circle, and it's going to be symmetric, which is really good. Okay, you can select your top view from here if you want. And now you need to just put in the dimension here. This is 80, and this is 50. You want to create the fillets here on the radius. We will go to this command, modify fillet. Select like this. 10mm is fine. Do the same for all 4 corners. This actually is 15. Why? We need 10. Finish the sketch and extrude this. We want to extrude it down, so it's -10. And it's not going to be a cut, it's going to be a join. Good. We need to create the holes here as well. And in the same fashion as we did before, we're going to create another sketch on the surface. And we're going to create a point. Create point. Somewhere around here. We're not going to stamp it to this one because we don't want it to be dependent on the radius. We actually want it anywhere, and we're going to constrain this point to, let's see if we can make our first sketch visible. Yeah, we're going to constrain this point to this. So in this direction here, it's so we have 60 between them, so it's 30. And in this direction, we're gonna have 15. Okay, that's our first hole. Select the hole feature, exactly like before. I guess we don't actually have a value for this, but it's gonna be slightly less. And again, we're gonna go to this one, extends to. It's gonna prompt us to select this face again. Okay. Now we need to mirror this, and actually we're gonna need to mirror it 2 times. First is going to be with this plane that we already have. I'm gonna go create mirror, feature, select the object. The plane is this plane. That's really simple. And now what we actually need to do is create a plane here, so we can use this to mirror it. We are gonna go back to the construct. And we're not going to choose plane long path, it's going to be actually an offset plane this time. But here, instead of a distance, we're going to go to object. So to object, we're going to select an offset plane, offset it from this one. And we're going to select the location we want to offset it, and it's going to be in this point. This is 2. Okay. Now we have another plane that's going to be linked to this point. So we can go and create another mirror. Objects to mirror, we will select these 2 objects now, the holes. And mirroring plane, our newly created plane, and click OK. Good. That looks pretty good. I don't like this, but we can go back and change it. That's the whole point of parametric design. We need to look back to where we designed this. It's this plane actually, yeah. We go back to this, so it's not 80, let's go with 60 and see how it looks. Yeah, that's exactly how I want it to look. Okay, now you can go ahead and add the fillets. This is a very... should always try to do this at the end. This looks like, yeah, 3mm should be fine here, and maybe you can add 5mm to this side. Okay. But this doesn't really look like a pipe, because a pipe needs to be hollow. And to do that, we just need to create another sweep, or rather 3 sweeps. So create another sketch here, create the circle just like before. This time it'll be smaller diameter, it's going to be 34, or that's what I had wrote down there. Finish the sketch, and exactly like before, we just need to sweep this along this path, but this time it'll be a cut. How about that? Now to join the two cuts, all the cuts together, we just need to do this exact same thing here. Now we can select this one because it's going to be perpendicular to this anyway. You can snap it like this. See, it's gonna snap to the circle. Here you can actually put the dimension like this and select the thickness actually, not the exact circle. You don't need to put the exact diameter, you can do it like this to control the wall thickness. Finish the sketch. Sweep. Select this. Select the path you need to... When you use one of the sketches in a 3D geometry, it'll hide it automatically. So what you need to do is unhide it if you want to use it again. Single path cut. That's not good. That's not what I wanted. Profile. Cut. Yeah, that's... Constrain it like that. 1.5. Right, sweep this one like this. I need to find the sketch path, cut, okay, and done. And there you go. Now you can hide whatever you don't need, all the construction elements, and there you go. That is how you have a fully parametric pipe design. And this now becomes very easy to change. You can go back to the sketches every time you want and change the value here like this. It's very easy to do, and you will not have any headaches. And like I said, with the snap of your fingers you just change it and it just works. So thank you for watching. I hope you enjoyed this tutorial. Let me know what you think. Is it too fast? Is it slow? Regardless, write down in the comment section below. Don't forget to leave a like and subscribe to my channel. Thank you and see you next time.